Performance isn't a feature you add at the end of a sprint. It's a forensic liability audit that starts on day one. Welcome to the QA revolution. Today we are going deep. We're moving beyond simple load tests into the guts of your system, threads, memory, and network bottlenecks. We are looking for the knee of the curve, the exact point where your system stops scaling and starts dying. Let's get to work. Section 1. Understanding the difference between load and stress testing. They are not the same, and confusing them is a rookie mistake. Load testing validates system behavior under expected traffic volumes. It's about ensuring you meet your service level objectives under normal conditions. If you expect 10,000 users, you test 10,000 users. You verify that response times stay within your 200 millisecond threshold. Before we dive into stress testing, if you believe that quality is a methodology, like this video and subscribe to the QA revolution. We don't rely on luck here. We rely on data. Hit that subscribe button to join the most technical QA community on the planet. Stress testing is different. It pushes a system beyond its breaking point to observe how it fails and, more importantly, how it recovers. Also known as fatigue testing, this is where we uncover data corruption, cascading failures, or security vulnerabilities that only emerge under extreme duress. We want to see if the system recovers gracefully or if it requires a manual restart. If it can't self-heal, you failed the audit. 90 seconds in. Are you still with me? Good, because we're moving from the what to the why. Let's talk thread contention. In high concurrency environments, thread contention is the primary cause of throughput flatlining even when your CPU looks fine. Contention occurs when multiple threads compete for the same shared resource, like a synchronized block or a database connection pool. When context switching rates spike and your threads enter a block state, your system effectively becomes single-threaded. That's a death sentence at scale. To fix this, we need thread dump analysis. We look for deadlocks where threads are waiting on each other in a circular dependency. We also look for starvation, where low priority threads never get CPU time because your high priority tasks are saturating the scheduler. Fixing contention requires strategy. Use lock striping to divide shared resources or concurrent data structures like concurrent hash map. Or better yet, implement lock-free algorithms using atomic variables. In the QA revolution, we don't just find locks, we eliminate them. Now let's talk about memory. If your threads are fine but your latency is spiking, you probably have a garbage collection problem. Managed runtimes like Java or Go use garbage collection, but it comes at a cost. Stop the world pauses that destroy your P99 latency. Heap sizing is a balancing act. Too small and you get frequent garbage collection cycles. Too large and those full collections last for seconds. 3 minutes in. Still awake. If you're a developer, you might be sweating. If you're QA, you're taking notes. Let's talk generational theory. Most objects die young. Tuning your young generation space correctly prevents short-lived objects from being promoted to the old generation. Old generation collections are significantly more expensive. In a high-scale environment, promotion is the enemy of performance. Your choice of collector matters. G-1-G-C is the standard, but for ultra-low latency, you need Z-G-C or Shenandoah to keep pauses sub-millisecond. Parallel G-C is fine for batch processing where individual pauses don't matter, but for user-facing AP it's a liability. Audit your collectors. You can have a perfect runtime and still have a slow system. High-scale systems are distributed and the network is often the hidden killer. Bandwidth is volume, latency is time. In high-scale systems, latency is usually the bigger problem. A 100 millisecond hop is an eternity. Common bottlenecks include TCP head-of-line blocking, where one lost packet stalls the entire stream. It's a cascading failure waiting to happen. Don't ignore DNS latency. Slow name resolution can add hundreds of milliseconds to every new connection. That's invisible to most monitoring tools. Mitigate these risks with connection pooling and keep alive headers. Use CDNs to move your data closer to the user. Shrink the network. To manage what we've discussed, you need to monitor the golden signals of SRE. If you aren't tracking these, you're flying blind. 4.5 minutes, we're halfway through. Let's talk about why average latency is a lie. This is the heart of the audit. Average latency is a liar. It hides the suffering of your most important users. In the QA revolution, we focus on P95 and P99. The P99 is the time it takes for the slowest 1% of requests. These are the users who are about to walk away. They are your real audit metric. Throughput is the number of requests you handle per second. High-scale systems must maintain stable throughput even as concurrency increases. Watch your error rate. At scale, a 1% error rate on 1 million requests is 10,000 failed transactions. That's a disaster. Saturation is your early warning system. If your CPU is at 80%, you're nearing saturation. Latency spikes are coming. Prepare for them. Finally, track efficiency. How much hardware do you need to process 1,000 requests? Tuning is about increasing throughput while lowering cost. Performance testing is not a one-time event. It's a continuous data-driven process. Correlation is the key to the forensic audit. Correlate high-level KPIs with deep dives into thread states, garbage collection logs, and network behavior. That is how you find the truth. 6 minutes, we're in the home stretch. Let's talk about the mindset of a forensic performance engineer. It's not about passing tests. The mindset of a performance engineer is simple. Assume nothing. Verify everything. Your code is guilty until proven performant. Trust the data, not the developer's intent. The system doesn't care about what you thought would happen. It only cares about what actually happens. Embrace the break. Finding the breaking point isn't a failure. It's the only way to ensure the system is resilient. We break things so they stay fixed. Start with a baseline. You can't measure improvement if you don't know where you started. Every audit begins with a baseline. Isolate your variables. If you change 3 things at once, you don't know what fixed the problem. One change, one test, one result. Automate your audits. Performance testing should be part of your CI/CD pipeline. If it's manual, it's already obsolete. Stay methodology driven. 7 minutes. Almost there. Don't test in production unless you're a madman or a genius. Usually you're just a madman. Use a staging environment. Your staging environment must be a mirror of production. If the hardware is different, your performance data is fiction. Don't base your audit on fiction. Use realistic data. If your database has 10 rows in staging but 10 million in production, your queries will behave differently. Test with scale. Performance is a culture, not a task. It belongs to the developers, the SREs, and especially the QA engineers. It's a shared responsibility. Stop guessing, start measuring. Every millisecond you save is a win for your users and your bottom line. Audit your way to success. When your builds stay green, it's not luck. It's because you did the work. You audited the liability and built a methodology that works. We've covered a lot today. Load versus stress, thread contention, memory management, and the golden signals. This is the foundation of the QA revolution. If this deep dive helped you, hit the like button. Subscribe for more forensic audits and join the revolution at QArevolution.com. Grab a Diet Mountain Dew and get back to the logs. I'm Ron, and I'll see you in the next forensic audit. Stay technical. Green builds are not luck. They are methodology. This is the QA revolution. Always methodology, always technical. See you at the next breakpoint.